Hello, welcome back to Ken O'Connor Racing. This is a project I've been thinking about for a long time, and I wasn't going to video it. I was just going to take some pictures, but hindsight being 2020, it's probably a lot easier to just go ahead and film this stuff. We're not going to film the process. I will tell you what we're doing, how we're doing it, but this is the first step. This project is a 6mm stroked blaster. It seems like it's going to work out on paper, but it's going to just barely work out. But we're going to give it a shot here. Money-wise, this isn't going to cost us a lot. Time-wise, I'll be shocked if we finish this crankshaft today. This is probably the most precise machining that we can do in this shop. There's no room for error here. Any error at all. Half thousandths indicating this stuff. It's just going to translate right through the whole crank. You'll never get this thing straight. We checked this before we took it out. This crankshaft was 1/1000ths out on one side, 2 on the other, and it wasn't where the webs were twisted. So we're pretty confident we can get this thing right on the money. What Tarmo's doing, and in case you don't know who Tarmo is, Tarmo's he's from the old country. He's from Estonia, and I'll tell you what, for a guy that comes from a place that doesn't have electricity and they have to take a crap in an outhouse, this guy's pretty darn smart. So he's indicating. Put that finger away. He just waved at me with his middle finger. What he's doing here is we've already indicated the center of the gear head. He's going to indicate the hole, and like I say, this cannot be off at all. So once he gets the hole indicated, we're going to go ahead and move the center line of that hole off 3mm to achieve our 6mm stroke. What I got going on over here is I'm starting to make the bushings. If you try something like this, it's definitely doable if you got the patience. One thing I can't stress enough, this piece can't come out of this lathe. Once you start cutting, you have to make the bushing. You got to drill the hole and you got to cut the outside diameter. I've got a pretty good idea where the outside diameter is going to end up, but I have to wait for Tarmo to finish boring that hole before I can turn the outside diameter. So I'm working on the inside for the pin, and I'm going to make the bushing, and Tarmo's going to start machining that crankshaft, and we'll come back in a couple and show you what we got. Got the first web finished. We ended up at 1 inch. Tarmo said it was going to be 1 inch 100. It's actually 1 inch 103. So now I've got my dimension for my bushing that I'm going to press in. The one on the left is the one that just came out of the jaws on the milling machine with the offset, the 3mm offset. The one on the right is the standard web. So we're going to get that set up in the Bridgeport and do our offset, bore that hole, and start making some bushings. Well, we got the machining process finished. I got my 2 bushings and these great big holes. Look how thin it is up here. And you know, I'm hoping a lot of you guys don't think this, but no, this isn't going to blow out this way. When this is welded, it's the same thing. It doesn't know the difference. It's still going to be just as strong as any crank, but we offset that 3mm, and that's basically the minimum size of the hole in order to accomplish this. So the next thing I'm going to do is press these bushings in and then weld them. Got our stroker crank assembled, and I laid out a few different things here just to make some visual notes on this stuff. The one on the left, these are all blaster crankshafts. The one on the left, this is just a stock crank, stock stroke. The one in the middle, this is our 6mm stroke with the Vito's rod, and the one on the right, that's the hot rods, 4mm. So let me see if I can zoom in on this. I'm going to actually, the next shot you're going to see, I'm going to put this on a granite table and set a height gauge, and we'll make a determination how close the height is here to how close it is here. And I tell you, by looking at it, it looks pretty close. And then Tarmo's setting up to trench the cases right now, and that's where we're going to go next. Okay, we're over here at our gauging station, and this is the hot rods crank, and this is definitely not rocket science. All I did is set a height gauge to where the rod is off of these webs, and I'm just going to compare it to the 6mm that we just made. Well, this is all good news. This is the 6mm stroke, and on this dial over here on our gauge, this was set at 0 for the 4mm, And when we do the stroke at 6mm with the Vito's rod, believe it or not, it's actually it's shorter, not taller. So we can it's about 18 thousandths, yeah, about 18 thousandths shorter than the Hot Rod's 4mm. So no welding of the cases at all, and we can actually trench the cases less than we normally do. Not by much, but you know, maybe 10 thousandths less, and we'll be fine on it. Next thing you do, we're going to trench the cases. Here's the setup we're going to use to get these cases done. We've done a bunch of these things, but one thing to keep in mind, if you ever need anything like this done, just make sure the guy's not hitting this with a die grinder. That is not the way to do it. You have to indicate, very important, you indicate off the bearing race, not this part of the case. But you indicate, you get dead center of the surface for the bearing, the outer bearing race, and then we're just going to cut out part of the case here a little bit wider than the thrust washers on the rod, probably 20 thousandths wider, and then do the same thing to the other part, and we should have some pretty free movement of the crankshaft by the time we're all done. Tarmo finished up the cases on the trench, and we just did the normal dimension that we usually do, but hindsight being 2020, looking at that crank and where that rod ended up, it's possible. I don't know if it's going to work out on the top end of it, but it's possible to stroke this crankshaft even 7mm, and it would still fit in there. What I got here is got some old bearings that are in, you know, decent shape. I'm not going to put a lot of money into this. These will actually work. I'm going to sweat these in, and then go ahead and put my crankshaft in, get a cylinder on it, get a piston in there, and just kind of discover where all my timing's gonna end up, and we'll make some decisions from there. I've got my mock-up assembly all set. I've got my crankshaft in there, and I don't know that I'm even going to have to clearance this thing, but I'm not just going to automatically do it. It looks like it's pretty close, but we'll see where we end up. Next thing I'm going to do is put a piston on this thing. I'm only going to use one ring on the top of this for now, just to get my dimensions on my port timing. Before we even started this project, I made this little graph here where I spec the cylinder out, and that's basically the tops of the ports, and you know where the piston's going to move, and just kind of laid it out before we spent any time on this to see if it was going to work. And one thing we did calculate is we thought that the piston was going to be popping out about 100 thousandths, and it's impossible to get it exact because these rods are all over the place, but that's pretty darn close. So we came up all right there. Hear that? That means my rod is hitting my cases in the front. Not unusual. That's not a big deal. We're going to take that out. When I go the other way, I can just feel it rubbing the cases here, so we are going to have to take this back apart, clearance the cases. But and we knew this was going to happen, kind of hoping it wouldn't, but down here at bottom dead center, that's my piston hitting the cases. So we've got a couple of options here. We're going to take this apart anyway, and then I'm going to make a decision whether, depending on how hard that piston is coming in, whether I'm going to trim the bottom of the skirt on the piston, or if we're going to set these cases, take the crank apart, put the cases back together, set it up on the mill, and then go ahead and bore down into the cases so that the piston clears out. But so far, I've got high hopes for this. I think this is going to work out fine. Alright, I popped this cylinder off real quick off camera, and I did confirm it's hitting the cases. The piston is hitting the cases at bottom dead center. So what I'm doing here is I'm bringing my piston up to top dead center. I'm just going to reach in here real quick and just scratch a line, and that's going to help me make my decision whether I'm just going to trim a little bit off of this piston. I'm imagining once everything gets hot, I probably want a good 40 thousandths clearance down there, so that's going to be the minimum cut, but let's see where we end up. It's not hitting by much, so I scribed that line. That's going to help me make my decision. The last thing I want is when this piston is at top dead center is to have an opening at the bottom of the exhaust port. So that's why I did that. Alright, that's my line on my Weisco piston when that's at top dead center. So I've got a lot of room here. That's all, I don't know, that's quite a bit. Looks like, I don't know, 300 thousandths at least, so I think I got plenty of room. I'm just going to go ahead and shave this piston. Okay, I went ahead and I cut a little bit off the piston, the bottom of it, to clear the gussets in the cases. And what's going on now is I put some green modeling clay. We use this a lot in here. And I put it in the bottom of the cases, so when my piston comes down, it's going to sink into that clay, and that's how I'm going to check my clearance. Kind of using it like plastic gauge, I guess. But as you can see, I'm no longer hitting at the bottom. I can just roll this right over. So I'll check that clay and see where I end up. So shaving a little off the bottom of the piston solved our clearance problem, and that's what it was hitting, right here and right here. And my clay test was good. I got my 40 thousandths clearance. That's just a number off the top of my head. I mean, I know it's plenty. I'm just thinking that if you get any wear in this piston might rock a little bit, and that's plenty. I'm not even worried about it. But the next problem we got to solve is the rod. When it's coming up in the front and in the back as well, even though it's not hitting, I'm still going to clearance it. And this is kind of like when you do a Vito's. I'm just going to scribe a line, same thing here, and clearance this corner and this corner all the way down out to our cut down here, and that should get that crank to rotate freely. Alright, I had these cases apart, put them back together, and what we have now is a crankshaft that actually turns over. So I've got all my clearances set. The next thing I'm going to do is put a degree wheel on this and then discover my port timing. Alright, I got my degree wheel on here, and one thing I want to point out, you can't find top dead center accurately on an engine without a stop. That's what this is. I'm not going to get into a lot of detail about this. I'll shoot another video about this later, but I've got my stop set up, and what the stop is actually doing is it's stopping the piston before top dead center, and that's going to allow me to set my degree wheel. So when I come to one side of it, it's at 12 degrees, and I come to the other side, and that's also at 12 degrees. What that means is that this part right here, 0, let me zoom in on that. Zero at top dead center is actually top dead center, but you have to have that stop in there. That piece right there. Damn, I need a cameraman. But anyway, that's what we use. It's nothing fancy, but you have to have a stop to find true top dead center. Now I can discover my port timing. Okay, I rolled the engine around and took my readings on my degree wheel, and this is what I came up with. My exhaust opens at 88 degrees after top dead center, and transfer ports open at 114 degrees after top dead center. I'm a little shocked at this, and I know these rods are going all over the place, but I think I got a longer rod than normal. So the math is pretty simple. It's 360 degrees in a full circle. We're only going from the top to the bottom. So you take 180 degrees, subtract, this is exhaust, 180 degrees, subtract the 88 degrees, that leaves you with 92 times 2, because now you're going to come back up, and that equals 184 degrees of exhaust port duration. I'm not going to tell you what I'm going to do with it, but I am going to change it. And this is taking into consideration we're going to drop the bottom of the ports to the top of the piston height at bottom dead center. At 114 on intake, you do the same thing. 180 degrees minus 114 times 2 equals 132 degrees of transfer port duration. A little bit high, but I'm not going to sweat it. So the next thing I'm going to do is I'm going to port this cylinder, and that's basically all I'm going to show you for right now, and then we'll see how it works out in the final results. Thanks for watching. ConnorRacing.com.